Hello students, welcome back. In this video, I am going to solve exercise 1.5 of chapter 1 sets. So let us understand the concept which is required to solve the questions of this exercise. Complement of a set. Let U be a universal set and A be the subset of U. Then complement of A is the set of all elements of U which are not the elements of A. So let us understand this with the help of this example and also with the help of a Venn diagram. So first of all, I'll just explain you with the help of a Venn diagram. Suppose this rectangle is a universal set and here I have its subset A. Then complement of A. See, complement of A is a set of all the elements which are not the elements of A. So that means, see, this is A. That means its complement will be this. So we write it as A dash. So other than A, everything in universal set is complement of A. So same thing we will understand with the help of this example also. So a universal set is this. So 1 to 10 numbers. Then A is a set of odd numbers. So we can see here A is equals to 1, 3, 5, 7, 9. And then what will be A dash? See, whatever elements are there in A. So 1 is there, 3 is there, 5 is there, 7 is there and 9 is there. We will not take those elements. Other than these elements, we are left with 2, 4, 6, 8 and 10. So this is only complement of A. So once again, I'll just repeat. Complement of A is the set of elements of U which are not the elements of A. So I hope you have understood this with the help of the example and the Venn diagram also. Now there are some properties of complements of set which will be of help when we will be doing the questions. So first one is complement laws. So what are complement laws? A union A dash. A dash is complement. See, A dash I have told you. So this is complement. So if we do A union A dash, so from Venn diagram also we'll understand. See, this is universal set. This is A and this is A dash. So if we are doing union of A and A dash, what we will get? We'll get this entire thing. And what is this entire set? This is our universal set. So A union complement of A is equals to universal set. Same way, A intersection A dash. So here we can see if this is universal set, this is A and this is A complement. Then here we can see they are disjoint set. So they are not sharing even a single element. See, all the elements of A dash are different from all the elements of A. So that means if we do their intersection, our answer will be 5, which means empty set. So this property also you can remember. A intersection A dash is equals to 5 means empty set. So A union A dash is equals to universal set and A intersection A dash is equals to empty set. Now next we have De Morgan laws. So De Morgan laws are very important because so many questions we can solve with the help of these laws. So what are these? See, A union B is if we take its complement. A union B is complement, it is equals to A complement intersection B complement. And the other one is if we do intersection of A and B and take its complement, then the answer will be A complement union B complement. So these two are De Morgan's laws and it's very easy to remember. See, when we are doing here union, A union B and taking its whole complement, then here it will be intersection. The individual complements we have to take an intersection. Here is A intersection B is complement. See, here intersection and whole complement. Here union. So if here it is union, then here will be intersection. If here it is intersection, then here it will be union. So here whole intersection, like whole bracket, here whole, sorry, not intersection, complement. So here we are taking whole complement and here the complement will be individually on A and B. So easily we can remember this way. Then this was the first law, complement law. Second one is De Morgan's law. Third one is law of double complementation. See, what is law of double complementation? If we take complement of A complement, that will be equals to A itself. So very important. Again, see, if this is A and this is A complement. See, if you are taking its complement, it will be A itself. Then fourth one is law of empty set and universal set. See, this is always true. If we are taking the complement of empty set, that will be universal set, and if we are taking the complement of universal set, then it will be empty set. So let's do now exercise. So I'm going to start exercise 1.5, and these two concepts, the De Morgan laws, complement laws, and then law of double complementation, law of empty set and universal set. These are few properties which we will use, and also complement we are going to use in this exercise. So let's start. In first question of exercise 1.5, it's given universal set, then set A and set B is given to us, set C is also given. We have to find these. So let's start. So A complement, first of all I have to find. See, when we are finding complement of any set, you just see the elements of the given set. So other than this, other than elements of A, I have to take all the elements. I have to consider all the elements from universal set. So 1 is there in A, so that means 1 will not be there in A complement. 2 is there, 2 is here also, 3 is here, 3 is here also, and same goes with 4. So that means 1, 2, 3, 4 will not be in A complement set. So which elements will be there? All other elements of universal set. So 5, 6, 7, 8, 9. So all the elements other than A, we have to consider in its complement. So second part is B complement. So same way, see, from where we have to take elements, elements will always be taken from universal set. So elements of B are 2, 4, 6, 8. So other than 2, 4, 6 and 8, we have to consider all the elements. So all other elements are 1, 3, 5, 7 and 9. See, elements of B are 2, 4, 6, 8. So in B complement, these elements will not come. And whatever other elements apart from these elements will be included in B complement. So next, third part we have to do. In third part, we have to find A union C whole complement. See, if you want, there are two ways to do this question directly. If you want, first of all, we can find A union C and then write its complement. Or the other way is that we can apply De Morgan law. So A union C and its whole complement, it can be written as A complement intersection. Here union will be changed to intersection and C will be changed to C complement. Now we can write their values. So what is A complement? We have found just now. So A complement is 5, 6, 7, 8, 9. C complement. So let's write C complement also. So first of all, we have to see the elements of C. Elements of C are 3, 4, 5, 6. So other than these elements, we have to consider all the elements. So 1, 2, 3, 4, 5, 6, 6 there. 3, 4, 5, 6. Then 7, 8, 9. So in C complement, these elements will come. So 3, 4, 5, 6, I don't have to consider. 3, 4, 5, 6, if I am not considering. So remaining elements are 1, 2, 7, 8, 9. Now its intersection, we have to take intersection. I have explained to you in the previous video. Intersection means the elements which are present in both the sets. So here 7, 8, 9 is present in both the sets. So that means A union C's complement is equals to 7, 8, 9. So let's do fourth part. See, fourth part directly, I'll show you directly also we can do. For third part, I have done by applying De Morgan's law. So both ways it can be done. So now fourth part directly I'll do and I'll show you. So it is A union B's complement I have to find. So let us find A union B first of all. So A union B is, first of all, when union we are writing, let's write all the elements of first set. So A's elements I am writing 1, 2, 3, 4. Then B's element 2 and 4, it's already there. Then 6 and 8. 6 and 8. So I have to consider its complement because A union B is complement I have to find. So let's take its complement. So I, from universal set, I don't have to consider 1, 2, 3, 4. Then 6 also I don't have to, then 5 I have to write. 6 I don't have to take. 7 I can write, 8 is there, and then 9. See, A union B's in complement is 579, and also you can do it by applying De Morgan's law. You can find it by writing it as A complement intersection B complement. So I have done first part, second part, third part, fourth part. Fifth is A complement's complement. So this also double complementation we have done. See, double complementation is, if you are taking the complement, A complement's complement, if you are taking, it will be A itself. So A's value we can write A is equals to 1, 2, 3, 4. So double complementation law states that if we are finding the complement of a complement, it will be equals to the original set itself. So let's do the next last part of this one. Last part is B minus C's complement. B minus C's complement. This is sixth part. So B minus C, difference of two sets we have learnt in the previous video. So B minus C, first of all I'll find. B minus C means you have to, in set B only you have to see all the elements. So only those elements which are coming in C also you don't have to consider. So 2 we can write because 2 is not there in C. 4 we cannot write because 4 is there in set C. Then 6 we can write. No, 6 also we cannot write because 6 is also there in set C. We can see here. Then 8 we can take. 8 we can take. So B minus C, in B minus C only two elements will come, 2 and 8, because if we consider set B, in set B 4 and 6 they are also coming in set C. So that means in B minus C these two elements won't be there. So its complement I have to find. B minus C is complement. That means other than 2 and 8 all the elements will come from universal set. So that means 1, 3, 4, 5, 6, 7, 8 will not be there, and 9. So B minus C's complement is this. So other than 2 and 8 all the elements we have to consider in universal set. So with this we have completed first question. Let's move towards the next question. So here universal set is given to us. Find the complements of the following sets. So A, B, C and D, four subsets of a universal sets are given to us. We have to find their complement. So let's start A complement. A complement means other than these elements A, B, C. So A I don't have to take, B I don't have to take, C I don't have to take, all the other elements I can write. So A complement will be equals to D, E, F, G, H. So second part, B complement. B complement, see B's elements are D, E, F, G. D, E, F, G. These elements I don't have to consider. Other than these four elements, all the elements from universal set I have to consider. So B complement is equals to A, B, C and H. Then third one is C complement. C complement means all the elements of C I don't have to consider. So C has A, so A will not be there. Then it has C also, it has E also, it has G also. So other than these four elements, all elements from universal set I have to consider. So C complement is equals to B, D, F and H. See, I'm just scratching the elements of C so that it will be easy for us to write. Now let's find the next one, which is D complement. See, D complement, again let's just scratch the elements of D so that it will be easy for us to write. So F complement means in D complement F won't be there, G won't be there, H won't be there, and A will also not be there. So remaining elements I'll write. Remaining elements are B, C, D and E. So with this we have completed question number 2 of this exercise. Also let's move towards the next question. Question number 3. Taking the set of natural numbers as universal set. So natural number we have to consider as universal set. So here U is equals to set of natural numbers. Write down the complements of the following set. So complements of the following sets we have to write. So complement means these elements we don't have to consider, so it will be very easy. So first one X, such that X is an even natural number. See, if X is an even natural number, so that means in natural number, how natural numbers are? Natural numbers are like 1, 2, 3, 4, 5, 6 and so on. All the numbers. Okay. So if even numbers I am not considering, like 2, 4, 6. So which numbers are left behind? Odd numbers. So that means X, its complement will be what? X, such that X is an odd natural number. Odd natural number. We can also write it as set A. Here I'll just write. So A we can write like this. I'll just write A. Second part. Second part I'll just write it as set B. So because complement means we have to write that set which does not contain these elements. So second one is X, such that X is an odd natural number. See, if X is an odd natural number, its complement will be opposite. X is an even natural number. So its complement will be even natural number, because even natural number will not contain odd numbers. So here we can write this set. Then third one. Third, I'll be writing as set C. So what is our set? X is a positive multiple of 3. So we can write here X such that X is not a positive multiple of 3, because we don't have to consider this set. See, in definition of complement also I have explained, complement of A is that set in which all the elements are present which are not the elements of A, or all those elements are present in A complement which does not belongs to A. Okay, so with this concept we will be writing these sets. If X here is a positive multiple of 3, then in its complement we'll write X is not a positive multiple. So its opposite will write positive multiple of 3. So like this same way we'll be doing fourth one also. I'll be writing it as set D. X is a prime number. So I can write D is equals to X such that X is a composite number. We can write, because primes number, if X is a prime number, its opposite will be a composite number, and also X is equals to 1. Why X is equals to 1? Because X is not a prime number, and one second, 1 is not included in composite also, and it will not be included in prime also. So we can write X is not a prime number, or X is a composite number we can write. And we can consider X is equals to 1 also, because if X is a prime number, so that means 1 is not there in this set. If 1 is not there in this set, we can take 1 in this set, because 1 is not a prime number. Okay, so set D we can write. So its complement we have to write X is a prime number. So its complement I am writing as X is a composite number, and X is equals to 1 also we can consider, because 1 is not a prime number, that's why it won't be present in this set. If it is not present in this set, that means it will be present in its complement. So fifth part we have to do now. So here itself I'll do fifth part now. So you can take screenshots or you can write along with me. Okay. So fifth part, x is a natural number divisible by 3 and 5. So x is a, so E I'll write x is a, so it's complement because we are writing. So x is a natural number which is, so here it's divisible by 3 and 5. So we'll consider the set x is a natural number in which x is not divisible by 3 and 5. Okay, so all the numbers here we are considering which are divisible by 3 and 5. So in its complement we'll consider those numbers which are not divisible by 3 and 5. So because opposite we have to consider the elements which are present in this set. Those elements won't be present in its complement. So sixth one now we'll be doing. I'll be considering it as set F. X is a perfect square. X is not a perfect square, is not a perfect square. So X is a perfect cube in second one or seventh one. I am writing it as set G. So X such that X is not a perfect cube. So easily you can write, because if it is not a perfect cube, so all the elements which belong in this set, they won't belong to this set. Okay, so eighth one we have to do. Eighth one, in this part it's mentioned x such that x is equals to, see x they have mentioned such that x plus 5. See, x plus 5 is equals to 8. That means basically if I solve this equation, I'll send 5 to other side. So it will become x is equals to 8 minus 5, which will give us actually x value as 3. So basically here in this question it is given to us in this set x is equals to 3. So what will be its complement? Its complement will say x is equals to set x such that x is not equals to 3, because we have to write its complement. If the set is equal, if in this set x value is equals to 3, in its complement x value will not be equals to 3. So next part we'll do now. You can take a screenshot. I hope you can just write along with me so that you won't miss any solution here. So I am doing now ninth part. So till 8th we have done. Ninth part I am doing. In ninth part, x value. Again here I'll just simplify. So it's given to us 2x plus 5 is equals to 9. If we solve this linear equation, first of all I am sending this 5 to other side. So I'll get 2x is equals to 9 minus 5. 9 minus 5 is 4. So x is equals to 4 by 2, which is equals to 2. So here in this one we are getting, here they have given to us as x value equals to 2. Then what will be its complement? Its complement, in its complement, I'm considering it as set I. I is equals to x such that x is not equals to 2. Because in this set x is equals to 2, so opposite we have to consider in complement opposite, in the sense the elements which are present in this set, those elements won't be there in its complement. So here if in this set x value is equals to 2, in its complement x value will not be equals to 2. So let's do next part, 7th. So in 7th set, it's given to us x is greater than equals to 7. See, if x is greater than equals to 7 in this set, in its complement x will be less than 7. Will not consider it as less than equals to 7. No, because here 7 is already included because equality sign is there. So only less than symbol we will use. So 10th, next one I'll take. X belongs to natural number such that, same way in 11th also we have to find the value of x. So 2x plus 1 is greater than 10. So I am just simplifying. 2x is greater than 9. See, 10 minus 1 will be 9. So x will be greater than 9 by 2. So that means in its complement, x will be less than equals to 9 by 2. See, completely opposite inequality I have to use. Here the inequality was greater than equals to, I took less than. Here the inequality is only of greater than, so I took less than equals to. Because complement sets we are writing. With this we have completed this question as well. Let's move towards the next question now. In next question, universal set is given to us, then set A and set B is given to us. We have to verify this. Okay, so let's do. See, first part is A union B is complement. For that, first of all, let's find A union B, because left hand side we have to prove this is equals to right. So individually, because we have to verify. If we have to verify, that means individually we have to solve both the sides and the answer should be same. So A union B. In A union B, all the elements we have to write. So first of all, A's elements I am writing 2, 4, 6, 8, and then B's element I will write. The elements which are getting repeated we don't have to write again. So 2 I have already written, then 3, 5 and 7. So its complement I have to write. So complement means from the universal set I have to find the elements other than these elements. So A union B's complement is equals to, so 2 I don't have to consider, 1 I have to consider, then 4 we don't have to consider, that means 3 we have to consider, then 5 also we don't have to consider because 5 is there. So 3 is also there. See, 3 is also there, 3 also we can't consider. So I'm just marking it so that we won't do any mistake while writing. So 1 I can write, remaining 2, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8 and then 9. Yes. So I have just scratched all the elements of A union B. So these elements I don't have to write in its complement. So A union B's complement is, this set is equals to, it has elements 1 and 9. Now let's find the same thing. This I have used left hand side. Now let's use right hand side. So what is right hand side of this one? It's A complement intersection B complement. So A complement means all the elements of from universal set I have to write, and the elements which I am taking should not be elements of A. So 2 belongs to A, that means it will not belong to its complement. 4 belongs to A, it will not belong to its complement. 6 belongs to A, it will not belong to its complement. 8 belongs to, so remaining I will write. Remaining elements are 1, 3, 5, 7, 9. So these are the elements of A complement. Its intersection I have to consider, I have to take with B complements element. So B's elements are 2, 3, 5, 7. So I'm just scratching them, 2, 3, 5, 7. So let's write remaining elements 1, 4, 6. See 1, 4, 6, 8 and 9. Now their intersection, we'll find intersection means only the elements which are present in both the sets, like the common. So 1 is there, I'm just writing 1 is there, then 3 is not there in both, 5 is also not there in both, 7 is also not there in both, 9 is present in both, 1 and 9 is present in both. So if we see left hand side, what was the answer? 1, 9. So right hand side is also equals to 1, 9, which means left hand side is equals to right hand side, hence it is verified. Now same way, let's do second part also. So second part, first of all, A intersection B let's find, then its complement we'll find. So left hand side I am solving. So A intersection B I'll find first, then its complement I'll find. So A intersection B means the common elements of A and B. So 2 is present in both A and B. So here we can see 2 is present in both A and B. Then 4 is not there. 6 is also not there. 8 is also not there. So let's double check. So all other elements, they are not getting repeated. So A intersection B is 2. That means if I am taking its complement, A intersection B is complement. When I have to take, I'll just write here. That means other than 2, all the elements will come from universal set. So it will be 1, 3, 4, 5, 6, 7, 8, 9. So this is A complement, A intersection B is complement. Let's do its right hand side now. Right hand side is A complement union B complement. So A complement and B complement, see, I found in the previous part also. I'll just from there itself, I'll just write. So it is 1, 3, 5, 7, 9. Sorry. Then its union I have to take with B complement, which is 1, 4, 6, 8, 9. See, I in previous part also we found A complement and B complement. From there itself I am writing, and then I am just writing their union. So union means all the elements I have to write. So all the elements I am writing first of all first sets. So 1, 3, 5, 7, 9. Again in here 1 we have already written, 4 we can write, then 6 we can write, 8 also we can write. So how many elements are there? 1, 3, 4, 5, 6, 7, 8, 9. So A complement union B complement, it is equals to A intersection B whole complement. Here, therefore left hand side is equals to right hand side. Hence, this result is verified. With this, we have completed fourth question also. Let's do next question now. In question number 5th, we have to draw appropriate Venn diagram for each of the following. So, Venn diagrams we have to draw. Okay, so let's do. First one is A union B. See, A union B, I have explained you in previous video. If this is universal set, and this is set A, and this is set B. Okay, so A union B is this thing, whole, everything. So this the shaded part, which I am shading with this white color. This is A union, this one is A union B. But what I have to draw? I have to draw A union B's complement. So that means other than this, I have to consider everything else. So I'll just highlight it with some different color. So this one, other than A union B, everything from the universal set it will come. So this the part which I've highlighted with the yellow color. So this is A union B's complement. You can just shade it. Okay, so let's do the next one now. See, next one is part second. I'll just draw. So I have to draw here A complements intersection with B complement. Okay. So this is set A, this is set B. So if this is set A, we'll just use different color. See, if this is set A, so what will be A complement? This is set A, which I have highlighted with the yellow color. This is set A. Okay, I'll just write it like this, and this is set B. Okay, I'll just write it with some different color, set B. So this one is set B. Common part, everything I have just highlighted. Okay. Now A complement will be what? A complement other than A. This everything. This part B also will come. Okay. Only this bordering will not come. So B is this part also will come. So this is A complement. This is A complement. With pink color I am highlighting this. And then B complement. So what is B complement? B complement means everything will come. Again, other than B, including this also. A's part also. This is B complement. Okay, this part also will come. So here I'll just very neatly I'll just draw it again. So this is set A, this is set B. So when I have to draw A complements intersection with B complement. So that means their common part I have to take, the part which is coming common in both. See, the common part which is coming in both is this one, because intersection means only the common. This part is there for A complement also, and this part is there for B complement also. So this thing is A complement intersection B complement, because it's a common part. If you see here, A complement, it has, see, A complement has this part of B also, and B complement has this part also. Okay, but these parts are not common. In intersection, only common parts we consider. So that's why only this shaded part we have to consider. But here in first part, unions, and one thing I will just explain you. If you can relate these two, I'm sure you are able to understand. A union B's complement is equals to A intersection A complements intersection B complement. You can see here the same shaded part we are getting here also. So this is also De Morgan's law also here it's verifying. Okay, so why, I hope you have understood. See, this part is not coming in common. So that's why when I'm considering A complements intersection with B complement, so only this outer part is coming in both. Okay, so let's do third part. See, third part is A intersection B is complement. A intersection B is complement. Okay, so this is A, this is B. So what is A intersection B? Okay, I'll just highlight it. A intersection B means their common part. So this is A intersection B. So if I have to consider its complement, okay, so I have to consider its complement. Complement means the part which I have shaded, that is A intersection B. Complement means other than this, everything will come. So here in this part, which I am shading it with yellow color. See, other than this intersection, like this part, everything is included in A intersection B's complement. Okay, so the last part, which Venn diagram, which I have to draw, see, you can draw a little neatly. I'm just drawing roughly. So this is A, this is set B. So the last one which I have to draw is A complements union B complement. We can just double check also. See, fourth part. A in complements union with B complement. Okay. So what we'll do here, first of all, we'll just mark, because union means everything will come. Okay, what is A complement? See, A complement is this part, what I am highlighting here. And then what is B complement? I'll just highlight with some different color. B complement is, see, blue one is A complement, and then B complement will be this one. See, their common part is not included. And then when their union we have to do. Union again you can see, other than this common part. Other than this common part, this one, everything is there. So union means everything other than this I have to include. So the shaded portion which I have shaded with both green and yellow, these parts will come here. So this is A complements union B complements. Same thing, you can see both of these are equal. Both of these are same. If you see both the Venn diagrams, both the shaded regions. See here also, other than this common, here also other than this common part, everything is coming. So here also by Venn diagram also you can see this De Morgan's law is satisfied. With this question is also completed. Let's do the next question, which is question number 6. So question number 6 says, let U be the set of all triangles. See, U be the set of all triangles. So when I'm talking about all triangle means all, like scalene, different types of triangles, scalene, isosceles, then equilateral, like whatever types of triangles are there, right angle, right angled triangle. So all triangles means all triangles will come. If A is a set, so this is universal set, and A is a set of all triangles with at least one angle different from 60 degree. See, A is a set of all the triangles with at least one angle different from 60 degrees. See, if one angle is also different, at least one means one can be different. More is also possible. So that means here equilateral triangle won't be there, because equilateral triangle's definition says that all angles should be 60 degree. But what is the condition here? A has all, like, different. A is a set of all triangles with at least one angle different than 60. That means all different triangles will be there other than equilateral triangle in A. Equilateral triangle's condition is that all angles should be 60. So that means here equilateral is not included. Here maybe scalene will be there, then isosceles will be there, right angle will be there, isosceles, then right angle. But equilateral is not there because the condition says only those triangles which has at least one angle different than 60. Then what is A complement? A complement is simple. If you know universal set and set A, so these things you don't have to include. Whatever is remaining, whatever is not coming in set A, that only will come in its complement. So that means in complement of A will be set of all equilateral triangles. Because equilateral triangles are not included in set A, that's why in its complement all equilateral, it will be a set of all equilateral triangles. With this, sixth question is also completed. It was very easy question. Let's do seventh one now. Seventh one is like fill in the blanks. Fill in the blanks to make each of the following a true statement. A union A complement. A union A complement, see, we have discussed in laws also. If we are doing union of A and its complement, it will become a universal set. Phi complement intersection A. See, phi complement we have learnt that phi complement is equals to universal set. See, both of them, universal sets complement is equals to phi. Phi means empty set. So phi's complement means universal set. This I have already explained you at the starting of the video. So universal sets intersection with A, this is always equals to A. So intersection means smaller set will be the answer always. Union means bigger set will be the answer always. This in previous video I have already explained you. So part third, A intersection A complement. See, A and A complement both are disjoint sets. Like, they don't have even a single same element. So that means these are disjoint sets. So disjoint sets intersection is always an empty set. So that means A intersection A complement is equals to phi or empty set. Universal sets complement. See, universal sets complement is what? Empty set. Its intersection with A. See, now intersections, whenever we are doing, just remember one thing, the smaller set will be the answer. So from these two sets, empty set and A, the smaller set is empty set only. So empty set's intersection with A will always be an empty set. So with this we have completed exercise 1.5 of this chapter. We are left with only one exercise of 1.6. So soon I'll be completing exercise 1.6 also. So I hope you are able to understand the very first chapter of 11th class with VLearn tutorial. I am hoping to see you in the next video. Thank you so much for watching the video.